this video, we're going to look at the Section B sample question. The height in meters of a rocket was measured from takeoff at 10-second intervals from 5 different locations. The data from the locations is given below, and you can download a copy of the data from here. So let's do that. Click on the data, and that's downloaded to my computer. So part A. Use the data to calculate the acceleration of the rocket. Remember to include the calculated error with your answer. I'm not going to go through the calculation in this video because the previous video did that, but let's start by moving the questions down a bit. In this row, I've put the acceleration and error. The first number is the acceleration, the second one is the error, for each of the data sets. So now we need to look at the values we've got: 4.36, 4.3, 4.38, 4.8 and 4.4. So we've got a problem with the fourth set of data here because our maximum error is 0.2 of a meter per second, and at 4.8 that's more than the maximum error away from the closest value, which is 4.4, which means that it would be reasonable to average the close values, but the large value of 4.8 is too far away from the other values to include in the average. So if this was in an exam question, what I would expect you to do is to make a statement to say that this value is not to be used because it needs more investigation, but that you can use the other values, which means that we can take the average of this plus this plus this plus this, but we need to do some more work on the value of 4.8, and our highest error was 0.21. So our answer to part A is 4.36 meters per second squared plus or minus 0.21 meters per second squared. And because it's our answer, let's change the pen colour to blue. So what factors might affect the precision of your answer? Well, in this question you've not been given a description of how these experiments were done, so you need to say that the factors that are involved in your calculation, which are the measurement of time, the measurement of height, and the method of recording the data, whatever that was. So you just need to mention the things that will affect the accuracy of your answer. Okay, part C, what method did you use to analyse the data? Briefly, and I emphasise briefly, describe what you plot. So what I'm looking for in this instance is the fact that we plotted t squared against height, not t against height. That's important. Then we find a regression because we created a straight line, so we could use linear regression, and then how you find the maximum error, which again we've done in the previous video. Part D, give your view on the quality of the data. What the examiner is looking for there is the fact that some of the data is outside the error bars of the rest of the data and therefore needs to be excluded from the calculation. Part E, calculate the maximum precision of the data. Well, that's the 2.1 because that's all of the other values are 0, but this one is 0.21. So you find the maximum value, and that's what goes down. So the maximum value is 0.21 meters per second squared, or 0.48%. And part F, describe ways in which the experiment might be improved. So you need to say something about improving the way that you measure the time, improving the way you measure the height, and make sure that the recording of the data accurately reflects what was actually observed. And that is how you get good marks on Section B.